All right, so we're going to really get into what this section is about and think about this example of a quadratic formula. This is written in what's called vertex form. We'll describe exactly what vertex form is in a minute, but first I want to understand why vertex formula works the way it does by doing some analysis with the equation. And this is the kind of analysis that I don't expect you to be able to do on your own right now, but by the time you get to calculus, you're going to be doing this kind of thing with equations there. So, first thing I want to think about is the 2 times x minus 3 quantity squared. What is the minimum or maximum value of that whole thing? So, one thing to remember is that anything squared is always positive, or maybe equal to 0. So, for example, if you do 0 squared, you get 0. If you do a negative number times itself, a negative number squared, you get a positive result. And a positive number times itself is also positive too. So that means that specifically x minus 3 squared is always greater or equal to 0. So that means x minus 3 squared is always greater or equal to 0. What about 2 times that? Well, if this is 0, then 2 times 0 is still 0. If x minus 3 squared is a positive number, 2 times a positive number is greater than 0 as well. So you might as well just throw on a 2 times this in front, and it would still work. So that means the minimum value of this expression is 0. And what is the minimum or maximum value of that thing minus 4? Well, if this whole thing comes out to be 0, then 0 minus 4 would be negative 4. And if this whole thing comes out to be something positive, you're going to get some positive number, minus 4, which is still greater than negative 4. So the minimum value of this is going to be negative 4. Now, what is the value of x that gets you there? That's what this is asking. The value of x that makes this 2 times something squared equal to 0, that's the thing that's going to give you your minimum value of y here. So, because this is already factored as 2 times x minus 3 times x minus 3, and the result on the right side is 0, that means x equals 3 will give you that value. Okay, I think another way to see how this is all working is to make a little table. I'll show you the way I would analyze this with a table. I'd pick some values of x that are either 3 or close to 3, like x equals 1, 2, 3, 4, or 5, and then plug them into the formula, but look at what happens to the various parts of the formula as you add more onto it. So, for example, if you plug in 1, that's going to give you 1 minus 3 is negative 2, and negative 2 squared is positive 4. If you plug in 2, you're going to get negative 1 squared, which is 1. Plugging in 3 gives you 3 minus 3 is 0 squared. And I'll skip some of that because you can do it yourself if you want to check. So these are like the kinds of numbers that you get as a result from squaring things. Then, if you multiply those things by 2, so for example, 2 times 4 is 8, 2 times 1 is 2, 2 times 0 is 0, and you get the same thing on the other side, then we see that, yeah, the minimum value of this expression is 0, which happens when x is 3. And then if you take all of these numbers and subtract 4 from them, well, we're going to get 8 minus 4 is 4, 2 minus 4 is negative 2. So we get these results here. And yeah, you can see that the minimum value of this whole thing, which becomes the y-coordinate, is -4. So the moral of the story here is that the vertex of this equation two times x minus 3 quantity squared minus 4 is the value of x is 3, and the value of y that gets you that is -4. And you could also just check this by graphing these xy points if you wanted. And yeah, when you graph the points, you get a parabola that looks kind of like that. And you can see the vertex is at that point there, 3, -4, where the y-coordinate is at its minimum, and that happens when x is 3. So that was me trying to explain why vertex form works. So if you have an equation written like this is what we call vertex form. And if it's written like that and you have x minus a number, that number that you're subtracting there is the x-coordinate of the vertex. So in this case, notice it was x minus 3. The x-coordinate of the vertex isn't -3, it's just 3. But then we had -4. You can think of that as plus -4. And that means the y-coordinate of the vertex here was actually -4. So here's another example that we can try with this. If you have this equation, let's get the vertex of it and then figure out if it's a minimum or a maximum point of the graph. So first of all, this is written in vertex form. And it's written as -4, so that means it's like the minus xv would mean xv is 4. And plus 6, that means the y sub v is 6. So the vertex is the xy point for 6. Okay, now how do we know if it's a maximum or a minimum point of the graph? Well, it has to do with this number -3 here, and if let's see what happens when we FOIL this out. If we do y equals -3 times x minus 4 times x minus 4 and then plus 6, the x minus 4 times x minus 4 part, that's going to become x times x is x squared minus 4x is going to give you a total of -8x. And then -4 times -4 is plus 16. We got that plus 6. Then we can distribute the -3 into there. So you get -3x squared plus 24x minus 48 plus 6. And then you can combine the -48 and the plus 6. And that's also known as -42. So this is another way of writing this equation, and you can see that what happened with the -3 out here is once it ended up getting distributed into everything, that becomes the a in like the ax squared plus bx plus c kind of form. So because that's negative, that means this opens downward. And if it opens downward, that means 4, 6 is like over here somewhere. That means that that is going to be a maximum point because all of the other points are going to be below the vertex. So I want to do a quick one more example looking at the different ways something looks in vertex form. These are actually all technically in vertex form, although they're not written exactly the same way. So I recommend trying these first on your own and pausing it here because I'll show you the answers right now. So for this first one, we can write this as y equals x minus something squared plus something. That's what I want to do because that's the vertex form. it's x something times x minus the x-coordinate of the vertex squared, and then plus the y-coordinate of the vertex. So if we want to have a plus 2 here, how do you subtract something to get positive 2? Well, it would be x minus negative 2. That's the same thing as x plus 2. And that means the x-coordinate of the vertex is negative 2. And the y-coordinate of the vertex, if we have a minus 1 here, we can write that as plus negative 1. And that means the y-coordinate of the vertex is negative 1. Okay, so we got that. Let's look at B next. So with part B, how could you write this as y equals x minus something squared plus something? Well, the minus thing, just like before, is going to have to be a negative 4, because minus negative 4 is the same as that plus 4. And we don't have another number on the outside here, so you could just think of it as plus 0, and that would be fine. So that means the vertex is negative 4, 0. And you got that. So let's look at this one now. You can write this as y equals that x squared. I want to write that as x minus something squared. And then we have the plus 7 on the outside. But x minus, let's see. X minus 0 is the same as x squared. So that means the vertex is 0, 7. So that's just a quick example of doing that. Here's a quick reading question for you to do. These reading questions, by the way, you don't have to copy them down. They're supposed to be pretty quick. You can just write your answer on your paper. Maybe write the actual equation, whichever equation you think it is, as the correct answer, but you don't need to write down all the choices you're not choosing. So anyways, sorry that video was so long. Thanks for bearing with it, and we'll do a tricky kind of application problem in the next video.